Assalamu alaikum and welcome to the project demonstration of Canal Blockage detection system. I'm Raiyan Rahman and from Department of CSE, MIST, and I will be taking you through the project demonstration of our project. This project was developed in interfacing lab of MIST by myself and my project members, the names of whom are flashed on the screen now. And with the guidance of our instructors, and names of whom will be flashed on the screen now as well. Next year. At first, before we go on to the project demonstration, I would like to give a background on why we are developing the project. If you consider the situation of urban cities, for example Dhaka of Bangladesh, then you will see that even a little bit of rainfall causes the narrow roads and streets of Dhaka city to be flooded very rapidly and immensely. But why is that? That is because we do not have, first of all, we do not have enough canals to clear out the water, and second of all, even if we do have the limited number of canals, we don't know if they are blocked and the situation of their blockage. For example, if we had a system in place that told us which of the pipes are currently blocked, what their blockage situation is, and give those data to Vasa and Dhaka City Corporation in real time, then it will give them, it would have gave them insight on which pipes are blocked, and they could take action to clear out those pipes very rapidly and prevent flood to happen, as they could take rapid actions. And we would like to also emphasize on the fact that we also incorporate the manhole detection system in our system, because when roads are flooded under 2 or 3 meters of black water, first of all, we do not know where the location of the pipes are, what their blockage situation is, and third of all, we do not know if any of the manholes in the road are open. And because of that, passers-by walking through that road in the water might fall into that manhole and possibly cause a very serious injury. And second of all, there is possibility of water contamination, as flood water might get mixed into the manhole water and contaminate the entire road's water, even possibly the Vasa pipes that are underneath the road. And so in our canal blockage detection system, we give you real-time data to Vasa and Dhaka City Corporation so that they can take rapid actions to clear out the pipes in case of rainfall, so that flood never occurs because of a little rainfall. And this system can also be incorporated in your homes, even in your rooftop, to detect blockage in the rooftop drainage system. So without further ado, now that we have the background out of the way, we'd like to take you on to the project demonstration. Here we have the prototype of the project. At first we have a pipe to demonstrate the blockage situation on. We also have a prototype of a manhole, and if we open the lid, we will be able to detect that. Now let's take you through the principle that we used here. We used LDR and laser combo to detect the blockage situation of the pipe. How did we do that? We used the very first principle of light, that is, when light travels to a certain medium, it travels in that medium with different intensity, different frequency and different wavelength. And as we can see, we have laser here and a LDR sensor there. The LDR sensor can successfully detect the intensity of the light. So for example, when we have air in this medium, we have different intensity of light falling onto that LDR, and it gives a certain value to Arduino. And when we have some kind of non-transparent block, it will give different value, and when we have water medium in that block, it will give different value. From this combination, we will be able to tell if there is any blockage in the front, back or middle of the pipe, and what kind of blockage that is. That is it a partial blockage or a full blockage? So that's the main principle that we worked on, and this will give us 8 conditional logics that we will be demonstrating very shortly. But first of all, let us give you a little bit of demonstration of our UI. So the UI is because of that, the fact that when pipes are blocked, so that the WASA or Dhaka City Corporation Authority can view the blockage situation of all the pipes of Dhaka City remotely from their headquarters, and then so that they can take necessary actions. We will also be sending SMS and email alert if a pipe is blocked or a manhole lid is open. So first, let's consider the first situation. The very first situation is there is no blockage or water in the pipe, and there is just air medium in the pipe. That is, there is no rain outside and the pipe is very clean. So as we can see, the on-spot LED is showing green. And if we go on to the UI, we'll be first greeted with the login option. So if the WASA employees log into the UI, they will be able to do one of the 4 following options. Present state, that is the current state of the pipe. Previous state, what the pipe was before in the previous state. For example, if it was blocked in the previous state, that will show red. Manhole situation, if the manhole lid is open or not. The history of the pipe, that is, since the system has been installed in that pipe, how many times blocks have occurred, and if they were cleared or not. So let's take you to the present state. The present state is showing green as there is no blockage in the pipe. So the on-spot LED is showing green, and the central UI in the WASA Authority's office is showing green as well. Now let's take you through the simple blockages. For example, this is the back of the pipe and that is the front of the pipe. Let's consider a situation when there is a wooden blockage. Wooden means there any kind of non-transparent blockage, suppose black polythenes, any kind of garbage material that is blocking the half of the pipe at the back. So we will see that after 3 seconds the light will go to yellow, and we are waiting this 3 seconds because we will not consider any garbage floating with the water that is blockage. We will only consider it a block if the block gets stuck there more than 3 seconds and so on. So this is considered a blockage if that is there for 3 or more seconds. So that is showing yellow, and the central UI shows yellow, and the block is at the back as well. If we remove that, the light will go back to green. It's green in the UI as well. Now let's demonstrate a full blockage at the back. See, most of the pipe is blocked and it shows red in the on-spot LED, and at this time we are sending an alert to respective cleaners so that they can clean the pipe. It will send a SMS and email to the number and email of the respective cleaner. A message was sent successfully and we see it showing red now as the pipe is blocked. If we remove that, it will go from red to green in a flash. This is why this is real time. Now if we do this very exact same situation in the front of the pipe, it will give similar results, just the same results, exactly like this. So the pipe goes from green to red as there is full block at the front, at the exact front, and the UI shows red and front as well. So that was the very basic for blockage situations. That there is partial block at the back, full block at the back, partial block at the front, and full block at the front. Full block and partial blocks are at the front is very much likely to happen as garbage gathers at the front of the pipe. This is 80% of the cases. Now let's consider the situation when garbage has gathered at the very middle of the pipe. We can also detect that situation using the same technique. For example, if there is garbage at the middle of the pipe, that means that there will be water full water at the back, but there will not be enough water in the back because the garbage is hindering the flow of the water. So we will have water in the first two sensors, but we will have less water at the back. So let's consider that we were giving water at the front, but there is no water coming at the back. So it is showing red because there is full block at the middle, and it shows full block at the middle as well. If we do that at the other end, it will produce similar results. Now that was the fifth and sixth condition. Now to another interesting blockage situation. What if there is blockage at 20% level of the pipe? That is, siltation has occurred in the pipe and 20% of the pipe has been blocked. So there is partial blockage throughout the pipe. Let's consider that situation. So the back of the pipe is partially blocked and the front of the pipe is partially blocked. It goes to yellow and it says yellow as well. This will give the siltation situation. So these were all the blockage situation. Blockage at the front, blockage at the middle, blockage at the back, and it also. Now let's take you through the manhole lid open detection. So if the manhole lid is open, it will show that in the central UI in the manhole option from the menu. So as we see that when the lid is closed, the light is flashing as green. Now if we take the manhole lid open, the light will go from green to red. As the manhole lid is open, a respective signal will be sent to the respective personnel as well. If we turn the lid back off, the light instantly goes from red to green again. So that was the whole of our project. At the very center we have the pipe, and we are detecting the blockage in the pipe if it's in the front, at the back, or at the middle, and if the blockage is partial or full. And then we're also detecting if the manhole lid is open or not, and we were showing all that information in a central user interface and of course in the on-spot LED. Now just to summarize the project, if we look at the project, that will be the summary of the project. At the center we have the Arduino microcontroller. The input from the sensors are coming to the microcontroller, and in the microcontroller we are implementing the 8 decision conditional logics, and that is driving the on-spot LED, the thrust mechanism that will be implemented later, and then the decision logic from the microcontroller, we are using cable or GSM modules to upload that to a server or database, and then we're doing a desktop implementation here, and that desktop application is sending SMS to respective authorities, showing the warnings and alert in a real-time graphical user interface, and saving and showing the data for future. As we see, if we look at the history, it is showing all the blockages that have occurred in the pipes since the installation of this system. As we see just a bit ago at 4:54, there were 3 blocks, and we have tested this system from 2 p.m. and it's showing all the blocks here. So that was the project. Thank you for bearing with us. I hope this demonstration helped you to better understand our project. Thank you everyone. Assalamu alaikum.